Hello, Advanced Algebra 2 students, it's Coach DePaulo, and this is a video for lesson 8.6, and this is actually video 1 of 2. We are going to be doing example number 1 today. Now, all classes yesterday took down the notes for the bottom of this page. If you were not here the day before, if you could ask the substitute who's there for me today for a copy of the completed notes. She will give you a copy of the notes that fills out the bottom of this page. And example 1 up at the top will be blank. So we're going to be doing example number 1 together, and then also example number 4. And then tonight's homework and classwork for when this video is done is for you to go to the assignment and do problems 4, 5, and 6. So the first thing we're going to need to do is we are going to need to factor this equation and reduce it and get it into its reduced form so that we can find our vertical asymptote. Now, if you refer back to the notes down here at the bottom, we are going to have to use 3 different forms of the equation. We're going to have to look at reduced form here. We're going to have to look at the original form here. And we're going to have to look for the factored form here. Okay, and then down here for x-intercepts and y-intercepts, we're going to be looking at reduced form again. So let's go ahead and get this equation into those 3 forms. So the first form is original, which is this right here. So we're going to label it the original form. All right, the next thing up is we need to factor this. So this factors into x minus 5 and x plus 4 on the numerator, and then on the denominator it factors into x plus 1 and x plus 4. And we're going to label this factored form. And then x plus 4 is reduce, and so then that's going to lead us to x minus 5 over x plus 1, which is reduced form. Now, just want to kind of give you a preview. When we're done, this is what this is going to look like, and you can see we've got lots of things to do here. We've got 5 different things that we need to do, and then we need to put some points over here. So make sure that you are writing small enough to get all of that material in there. Okay, so the first thing we need to do is we need to find the vertical asymptote. So if you refer back to your notes, vertical asymptote is going to use the reduced form, and we're looking for values that make this 0. So basically we're looking for the restriction. So we're going to say that x plus 1 cannot equal 0. So x cannot equal negative 1. Now, that's the restriction, and we're looking for a vertical asymptote. And if you refer back to the notes, a vertical asymptote is a line. So we need to give it an x equals equation. So that x equals equation is going to be x is equal to negative 1. And we're going to come over to our graph, and we're going to put an vertical asymptote on x equals negative 1. All right, next up, we are going to be finding the holes. I'm going to go ahead and space these out so that you're sure about what belongs in each section. Okay, so if we go back here to our notes, and we're going to be looking at the factored form. And this time we're going to be looking for values that make the factors that reduced equal to 0. Okay, so basically what we're doing is we're going back to this factored form, and we're looking for the factor that reduced, and we're looking for its restriction. So we can say that x plus 4 cannot be 0, so x cannot be negative 4. Now, unlike the vertical asymptote, a hole is a point. And so a point needs an x-coordinate and a y-coordinate. So we have the x-coordinate, negative 4. Now to find the y-coordinate, we are going to plug negative 4 back into the reduced form. And this will lead us to -9 over -3. And so that means that y is equal to 3. So our hole is at the point -4, 3. So I'm going to come over to my graph, and I'm going to go to point -4, +3, and I'm going to put a hole. Okay, and where we're headed with that is eventually when I get to sketching, my graph is going to go all the way up to the hole and then jump across to the other side, but it will not go through the hole. So that's where we're headed with that point. All right, next up, we need to find the horizontal asymptote. So let's look at our notes. Our horizontal asymptote leads us to this section where we have Babo Botten eats DC. Now, the Babo portion stands for bigger on bottom 0. The Botten stands for bigger on top none. And the eats DC stands for equal divide coefficients. So let's go back in here and we're going to take care of this. So our horizontal asymptote, okay, horizontal asymptote tells us that we need to look at the degree. So we're going to come up here and circle this 2, and that is the degree of the numerator. And we're going to circle this 2, and that's the degree of the denominator. Now we have to compare them. Babo says if the degree of the bottom is bigger than the top. Well, we don't have that situation, but if we did, then the horizontal asymptote would be right here on the x-axis, bigger on bottom 0. Okay, the Botten says if the degree on the top is bigger than the bottom, which we don't have, but if we did, there would be no horizontal asymptote. Then what we'd have to look for is a oblique asymptote. So what we have is eats DC. The E in eats stands for equal. So these two are equal to each other. So we're going to write down here that we have a eats DC situation. And if that's true, then what we're going to do is we're going to take the leading coefficient, which is 1 on the top, and there's a 1 on the bottom, and we're going to divide them. So we're going to get y equals 1 divided by 1. Therefore, y is equal to 1 is our horizontal asymptote. So we're going to come up here on our graph, and at y equals 1, we're going to draw a horizontal asymptote. All right, next up, we need some points. We have two asymptotes and a hole. Now we need some points. So now that's going to lead us to finding the x-intercept. Okay, so our x-intercept, we are going to, if you look back at our notes on our x-intercepts down here at the bottom, we're going to look at reduced form, and we are going to set y equal to 0 and solve for x in reduced form. Then while we're here, let's go ahead and look. When we do the y-intercept, we are going to be setting x equal to 0 and solving for y. And what I should have written down here, and I did not, but I wanted to put a little star here, and we're going to say x and y intercepts are points. So we need x and y coordinates for them. So let's go back here. I'm going to go to my reduced form, and I'm going to set y equal to 0, and I'm going to solve for x. All right, and to solve for x, I'm going to multiply both sides by x plus 1. When I multiply the right side times x plus 1, I'm going to get x minus 5 because these are going to cancel. And when I multiply the left side by x plus 1 times 0 is just 0. So I get a 0 over here. Move the 5 over, so x is equal to 5. So my point then is 5, 0. So I'm going to go over to the graph, and I'm going to plot a point at 5, 0. All right, next I need my y-intercept. Okay, so we've already looked at that, and it said set x equal to 0. So here's our y-intercept. This time we're going to set x equal to 0. So we get 0 minus 5 over 0 plus 1. That's going to be negative 5 over 1, so y is equal to negative 5. So that puts my y-intercept at 0, negative 5. So I'm going to plot a point here. All right, so now we've got 2 points. And we can kind of see that our graph's going to do something like this. And what we need to do to be a little bit more accurate is we're going to find a point right there. So right underneath the graph, we're going to write additional points. Okay, so I'm going to choose 2 because I know that it'll give me a whole number, and I think 1 will also, but we're going to choose 2. So we're going to substitute 2 in for x. So y is going to be equal to 2 minus 5 over 2 plus 1, which is negative 3 over 3. Therefore, y is equal to negative 1. So this is the point 2, negative 1. So I got a third point on my graph, 2, negative 1. So now I'm ready to give this thing a sketch. I'm going to come up through here, and I'm going to slowly start to turn, but then when I get to that point, which is almost the key point, not quite the key point, but pretty close. Okay, so there's a pretty good sketch. All right, and now what you need to remember is that this graph and this graph are reflections of each other. And if you remember, reflections, every point on this will be also a point on this, except the coordinates will be inverse. So I'm going to label this over here inverse points. Now the key thing, and write yourself a college note, these inverse points are from the new center. So this point right here from the new center is 1, 2, 3, 4, 5, 6, negative 1. So 6, negative 1 is going to become negative 1, 6 in quadrant 2. So I'm going to go negative 1, 1, 2, 3, 4, 5, 6, and put a point right there, and that point is at negative 2, 7. And I'm going to label this point 1. I'm going to label this point 1. All right, so this is going to be point 2. So point 2 from the new center, that's coordinates 3, negative 2. So that's going to become negative 2, 3. So I'm going to go left 2 and up 1, 2, 3. So I get a point right there at negative 3, 4. And then I'm going to label this one point 3. And point 3 has coordinates 1, negative 6. So that's going to become negative 6, 1. So negative 6, 1 will put us right here at negative 7, 2. And now I have 3 great points. Now remember, this open dot is a hole, so we're going to stop at one side and then pick it back up at the other side. And that's it. Okay, that's it for our first example. Now what I want you to do is I want you to pause the video, and if you are in first or second period, I want you to work on example number 4 by yourself. And then if you are in third through 7th period, I would like you to start example 4 now, because we finished example 1 while we were in class. And then we're going to give you about 10 minutes to do that. And then you're going to turn back the video on to see how well you did with example 4. Okay, so hopefully you have paused a little bit. You've worked on example 4, and now let's go over to example 4 and let's see how we do. I'm going to be going just a little bit faster this time so that you have plenty of time to work in class. Okay, here we go. So first thing I'm going to do is I'm going to label this the original. Okay, now I'm going to factor. So first thing I'm going to do is I'm going to factor out a 2, and that's going to, I'm going to factor out the 2 over here, so because I know I'm going to factor it in a minute after I take out the 2. So let's see, that's going to be x squared minus 2x minus 8. So that's going to be x minus 4 and x plus 2. And then down here we're going to have x plus 4 and x plus 2. Okay, so this will be our factored form. Okay, and then these two will reduce. So I'm going to write reduced form over here equals 2 times x minus 4 over x plus 4. And just to save some space, I'm going to write reduced up here. Okay, here we go. Vertical asymptote. Okay, remember vertical asymptote comes out of reduced form, and I've got an x plus 4. So I'm going to say x plus 4 cannot equal 0. So x cannot equal negative 4. So remember, then that means that the equation will be x does equal negative 4, but for an asymptote. So now, if you notice on this graph, I have gone by 2's. So x equals negative 4 is going to be 2 lines over right here. And down at the bottom, I'm going to write x equals negative 4. All right, next up is holes. Okay, how do I know that's next? Because I'm just following the ledger down here at the bottom. So I'm going to go over here to holes. Okay, so now if you remember holes, I go to holes, I go to factored form and look and notice that x plus 2 got reduced. So that's where my hole is going to be. X plus 2 cannot equal 0. So x cannot equal negative 2. So now I'm going to go to reduced form, and I'm going to plug in negative 2 for x. 2 times negative 2 minus 4 over negative 2 plus 4. So this is going to be y equals 2 times negative 6 over 2. So this is going to be negative 6. So the hole then is going to be at negative 2, negative 6. So negative 2, 4, 6, right there is the hole. Okay, now I'm going to do that hole in a different color because that way I want to graph in a different color. Okay, next up is horizontal asymptote. Okay, so horizontal asymptote. Okay, if you remember horizontal asymptote, I'm going to look at the degree and the original. So once again, I have a degree of 2 and a degree of 2, so they are the same. So I have an EATS DC situation. So that means my equation is going to be y equals, I'm going to take the leading coefficient from the numerator, which is 2, and divide it from the leading coefficient in the denominator, which is 1. So that's going to be 2 over 1. So I get y equals 2 is my horizontal asymptote. Now remember, my graph goes by 2's, so y equals 2 is 1 line up. All right, then I've got my x-intercept. Okay, so again, hopefully that you're doing well so far. My x-intercept, I'm going to go back to reduced form and put 0 in for y. So 0 equals 2 times x minus 4 over x plus 4. And remember, I'm going to multiply both sides by x plus 4, and that's going to give me 0. So I'm going to have 0 equals 2 times x minus 4. I'm going to divide both sides by 2, so 0 equals x minus 4. So 4 equals x. So the point then is my x-intercept is 4, 0. My x-intercept is 4, 0. And just, I forgot to put my horizontal asymptote over here, which was y equals 2. All right, so 4, 0 on the x-axis, 2, 4, 0, right there. All right, now we're going to go to y-intercept. And so I'm running out of room a little bit, so I'm going to shrink these down. I know that you might not be able to do that, but hopefully you've saved enough room. So let me shrink these down a little bit. And I'm going to come over here and do my y-intercept. Okay, so y-intercept, I'm going to go back to reduced form and put in 0 for x. So y equals 2 times 0 minus 4 over 0 plus 4. So y equals negative 8 over 4. So y equals negative 2. So that gives me an x-intercept of 0, negative 2. So 0, negative 2 is right here. All right, 0, negative 2. All right, so here I am. Now I'm able to sketch my graph. Remember, I'm going to stop at the hole. I don't want to graph through it like that. There we go. Now, remember, as far as I forgot to mention oblique asymptote. The oblique asymptote is if when we get to bottom, if it's bigger on top, it's none because there's no horizontal asymptote. So then I have to look back to see if my numerator's degree is bigger by 1. But in this case, since I have an horizontal asymptote, I will not have an oblique asymptote. And just to make things match, let me make that red. That looks bad to me. Okay, and now we need to do our additional points. Now, notice I already have 3 points here, so that's all I'm asking that you have. So when we do our additional points, all you need to do is do the inverse points, okay? So I'm going to call this point 1 and point 2 and point 3. So from our new center, point 1 is 2, 4, 6, 8. So it's 8, negative 2. So 8, negative 2 becomes negative 2, 8. So I'm going to go from my new center, negative 2, 2, 4, 6, 8. So I get a point right there. And then point number 2 from the new center is 2, 4, negative 4. So 4, negative 4 becomes negative 4, 4. So negative 4, 4, that's right there. And then now remember, a hole on one side is an actual point on the other one. So my hole is at 2, negative 2, 4, 6, 8. At 2, negative 8. So I need to go negative 8, 2. So from here, I'm going 2, 4, 6, 8, 2. So right there. Oops, I'm going to get red right there. And I'm ready to connect. So here we go, way down there, start to go up. Uh-oh, hole disappeared, and there's the graph. All right, so there's your notes for example 1 and example 2, example 1 and example 4. Tonight your homework is problem 4, 5, and 6. Have a great evening.